Hello and welcome to this AimHi Live. Today I'm going to do high school levels, about ages 13 to 17-ish, and I'm going to do fractions and percentages. To be honest, actually, I say 13 to 17, this is probably more applicable to like anyone between 8 and 17, because some people get taught this really well when they're younger, and some people get taught it really badly when they're younger as well. And so either way, it may be useful to you. So we're going to start here. So who knows what this is? Yeah, it's a sponge. It's an actual sponge. It is a sea sponge. So I want you guys to tell me what you think would happen if you were to take a sea sponge and you were to squeeze it through a living sea sponge. So if you take a living sea sponge and you squeeze it through a sieve. So if you took a big sieve here with all its little holes in it, and you squidged it through the sieve, then what do you think would happen to the sea sponge on the other side? Anyway, that has nothing to do with the maths that we're going to cover today. I just thought it was interesting, so I just thought I'd throw it in at the beginning. Right, but here's the first question I want to ask in maths. And if you haven't already, by the way, probably good idea to grab a calculator, because this is going to be a particularly calculatory one. You can do it with your phone calculator if you want, but it's way easier if you've got like a scientific calculator or a proper calculator. Okay, so 1 million slots is saying if you squeezed a sea sponge through a sieve like this one, then it would go into small bits, but can be put back together. As Catherine is saying, it wouldn't be very nice for the sea sponge. So I agree, the sea sponge wouldn't approve of this, but ultimately the sea sponge could be squeezed through a sieve and it could reform on the other side, which is pretty cool. Anyway, right, so let's do the first question that I wanted to do. So I'm actually going to start more on percentages today, and then I'll go to fractions afterwards. So first, I just want to ask you this question. What is 32% of 25? Right, so the reason I wanted to start with this one, 1 million slots is correct, and so is Karina. Yeah, brilliant. So it is 8. The reason I wanted to start with this is because this is quite a good example of how percentages are often taught quite badly, because this question is way easier than it looks. So I don't know how many of you know this, but 32% of 25 is the same as 25% of 32. Now, 25% of 32 is something that people are more likely to know that 25% is just a quarter. So a quarter of 32 is, as you've all said, 8. I'll explain why this simpler example works, but I'll do that in a mo. First, I just want to ask you guys if you can do a similar thing. So can you get me 38% of 20? What do you guys think 38% of 20 is? Now, using the same thing that we were talking about before, 38% of 20 is the same as 20% of 38. So loads of people are saying 7.6. Eli is saying it. Karina, Jack, yeah, brilliant. First thing I wanted to talk about, and let's just go down to this lizard to talk about it, is the word of. So the word of in maths is the same as times. So the word of means times. So if you're ever asked to find 10% of 18, then that means 10% times 18. And this is really, really important because it actually makes things a lot simpler. So the fact that the word of is the same as the word times is such a crucial, central piece of knowledge to understanding maths, because it's used so many times. And you can think about it in like more simple terms. Let's say like a box of eggs. There's like 10 eggs in a box, and if you have 3 of those 10 boxes, 3 of 10 means you're going to have 30 eggs. 3 times 10. Okay, so 10% of 18 is the same as 10% times 18. So who knows what 10% is as a decimal? And actually, I'm more interested in knowing if anyone doesn't know what 10% is as a decimal. Because if everyone knows what 10% is as a decimal, then we can just move on to the next bit of what I want to cover. So Iachedi is saying 0.1, Eli is saying 0.1, and so Catherine is saying 0.1. Good. So 10% is the same as 0.1. Let me know if anyone doesn't know that, and I'll really quickly explain why. But otherwise, that means that 10% of 18 is the same as 10% times 18, which is the same as 0.1 times 18. So nobody is saying that they don't know why 10% is 0.1. Great. But by all means, if anyone doesn't know, just shout and we can go back over that. So yeah, 10% is the same as 0.1, which means that 10% of 18 is the same as 0.1 times 18, which is way easier to put into your calculator. Right, okay, so now can you guys tell me what the answer to this is? What is 72% of 59? So everyone do work this out and then throw your answer into the chat, and all the answers are pouring in are 42.48, which is great. Right, so just to really quickly go over why this is, 72% of 59 is the same as 72% times 59, and 72% is the same as 0.72 times 59. So this ability to take, because often maths is given to you in words and often it's given to you in huge amounts of text, which I always hate because my brain is very bad at dealing with text because I'm a bit dyslexic. And so the thing that you have to try and do is always turn the text, like the writing, into something that you can write into a calculator. So 72% of 59 is the same as 0.72 times 59, which all of you have got. Great. Okay, so let's say this lizard weighs, let's say it's a big old lizard and it weighs 12 kilograms, which is huge for a lizard. So this 12 kilogram lizard is going to feast overnight, and in its feasting overnight, it will increase in size by 13%. So this lizard is going to get 13% bigger. So what do you think the new weight of the lizard is going to be? Starts as 12 kilograms. It's going to get itself 13% bigger by eating eggs. Okay, so a couple of people got 13.56, and which is good. But let's just go through this in case anyone either couldn't get that or was doing it in a way that was quite slow. So what some people might do is find 13% of 12 kilograms. So you might find what 13% of 12 kilograms is, and so that's going to be 0.13 times 12, and you'd find that that's 1.56 kilograms. And you can find that in your calculator. So because that's 1.56 kilograms, you might have added that on to your original 12 kilograms to get 13.56 as your final. Who of the people who got an answer, who did it that way and who did it another way? I'm interested to know, because this is not the fastest way to do it, and there's a much better way to do it, which is what I'm going to show you now. So if your 12 kilogram lizard is increasing by 13%, then what you have to think of is that to begin with, your lizard was 100%. It was just the lizard as it is, as it was, that's the lizard to begin with. It's 100% lizard. Now, if you increase the lizard by 13%, then your new lizard is going to be 113% of the original lizard. So instead of doing 13% and adding it on, if instead you do 113% of your 12 kilogram lizard, then that is the same as, what's 113% as a decimal? What do you guys think? Of is the same as times. 12 equals, we know the answer is 13.56 kilograms. And so Eli, almost right. 113% is not 1.3, it's 1.13. Because remember, the word percent, let me just break this down as well for anyone who doesn't know this. Per means divided by, so that's / or divided by, and then cent means 100. So divided by 100, that's what percent means, divide by 100. So that's why 50% is the same as 50 divided by 100, percent divided by 100, and 50 over 100, as you can work out, is a half. So 50% is a half, because a percent just means divided by 100. That's all it is. It's often presented in quite a weird way because you learn it when you're quite young, but it's literally just means divide by 100. So yeah, 113% is 1.13. Right, perfect. Right, now, next thing I want you to do is, if instead of eating eggs, let's say that it lays eggs. So now we're going to have the same lizard, so it's still 12 kilograms, but this time it's going to lay eggs. And as a consequence, it's going to get 21% smaller. So it starts at 12 kilos, it's going to get 21% smaller. I want to know what percentage you're going to times 12 kilograms by and what the final weight is going to be of the lizard. Go. Okay, so originally your lizard started at 100%. Because it's getting 21% smaller, it's going to be becoming, what percentage will it become? So 100% is 12 kilograms. And then because it's going down by 21%, the new lizard is going to be 79% of the original. So I can see some answers coming in that look good. So because we are, I'm just going to keep going through why. So because we're going down by 21%, we go from our original, so 100% lizard, which is 12 kilograms, down to 79%. So the question is, what is 79% of 12? And so for those of you who've already done it, 0.79 times 12 equals 9.48. I'm just going to do one more example of this to make sure everyone's got it. So let's say that this lizard comes across another lizard that is much larger than it, and the two lizards decide to join forces, much akin to like a transformer relationship, where they just attach together and form like a mega lizard. So this new mega lizard is so much bigger than the original 12 kilograms that this lizard gets 105% bigger. So this lizard is going to get 105% bigger than it was before. So how can we work out the new weight of the lizard? So our original lizard is 12 kilograms, which means that we start with 100%. So 100% of our lizard to begin with is 12 kilograms. Now, because our lizard's getting 105% bigger, that's a huge increase. And so we're going from our original 100% up to 205%. So our new lizard is going to be 205% of what it was to begin with. So 205% of 12 kilograms, lizard merge. 205% of 12 kilograms is the same as 205%. So percent means divide by 100. That's actually why the symbol looks like this. It's got a divide sign, and then it's got two zeros for divide by 100, divide by 100. So 2.05, and then of is the same as times 12. Yeah, it's going to be 24.6 kilograms. Perfect. Okay, great. Right, now, that was brilliant. Now I'm going to go across to here. What's strange about this box of eggs? And I wonder how many people will notice this, because it maybe depends on what country you're in. Jack is saying exactly what I was thinking. There are 10 rather than 6 or 12. I don't know. In fact, I'm really interested to know if people say what country they're in and say what the normal number of eggs that comes in a box is. I'd be really interested to know what people say, because in the UK, you only get eggs in boxes of 6 and 12, and maybe 24. But it's always multiples of 6 or 12, because it's just been tradition that eggs have always been sold in a dozen. And these, it might seem weird because like most of our system is built on tens and hundreds and thousands and things. But the reason why people used to prefer 6s and 12s is because there are more, this is quite an interesting bit of maths, I guess. There are more numbers that you can divide by. So if you've got 12, then you can split it into thirds, you can split it into halves, you can split it into quarters, you can split it into sixths. There are just way more fractions that you can split it into compared to 10 that you can only split into halves and fifths, and that's it. I mean, you can split them, but you can split these into tenths and these into twelfths, I guess, but I was ignoring those. Anyway, basically there are loads more numbers you can divide by, which means it's much easier to like take fractions of things when you're buying stuff at the market and stuff. So anyway, that's why 12s are so prevalent in trade, and because it's just much easier for people to like split things up. Next thing I want to know is, let's take these eggs and let's say that they cost, let's put a price on them. Let's say that these eggs, which are not a dozen, there's 10 of them, cost £2.50 now. And they are £2.50 because they have been reduced in price by 20%. So 20% has been knocked off the price, and now the eggs cost £2.50. So my question to you guys is, what did the eggs cost before? So if you start with the number 100 and you reduce it by 20%, and the answer is 80. Great, so Jack's got that, perfect. Now if you take 80 and you increase it by 20%, then what do you get to? Okay, everyone's getting this. T, Eli, great work, guys. So yeah, 100, 20% smaller is 80. And then if you increase 80 by 20%, so Catherine, 1 million sloths, Eli are all saying 100. Okay, so you're all wrong actually. So 80 increased by 20% does not get you back to 100. So what is 20% of 80? 20% of 80 is 0.20 or 0.2 times 80, which is 16. So if you increase 80 by 20%, then you're increasing it by 16, and you get to 96. So Karina, yeah, that's a great method, and we're going to talk about how that works now. But I just wanted to point this out to people because this is so important. Percentages are not like almost every other bit of maths that you do, like multiplying, dividing, adding and minusing. Percentages are not reversible. You can't just do reduce by 20% and then increase by 20% and expect to get back to where you started. Percentages don't reverse like that. So actually you have to think quite carefully before trying to do a percentage backwards. So when we were doing these eggs, I told you that they're £2.50 now, and before that they were a higher price and they've been reduced by 20%. So there's an element in this question of going backwards in time, and that's what you should always look for with percentages. And as soon as there's this idea of what was the price before, or what was the size before, or whatever, whenever there's that element of going back in time, alarm bells should be ringing and you should be thinking, right, we need to do this slightly differently. So let me explain to you how this works. And it looks like, okay, so here I told you that I'm just going to kind of redraw these eggs here, because I used to draw this as a picture to help myself to visualize it when I was doing it. So here is our box of eggs, which I'm just going to symbolize with one egg. And then I would draw like a kind of dividing line to help me map out where is before, to help me map out before and after. So let's fill in all the information that we know. We know that after the reduction in price, the eggs are £2.50, and we know that they've been reduced by 20%. So we know that the journey to go from before to after was to reduce them by 20%, so minus 20%. And the thing we don't know is how much it cost before, so I'm just going to fill that in with an X because we don't know what it is. Now, if you were to write this out in algebra, then you would write that X, the price before, we're going to reduce by 20%. So if you're reducing something by 20%, then just a really quick recap of before, if you start with 100% and you're going down by 20%, then you are trying to find 80%. So to go across here, you're timesing by 80%, which is the same as reducing by 20%. So we're going to do x times 80%, which is times 0.8. And that is going to equal our £2.50, or 2.5. So the unknown price before times 0.8, so 80% of the price before will give us £2.50. So a 20% reduction, because if you're doing 80%, then that's a 20% reduction of the price before will give you £2.50, which means that you can get the price before by doing 2.5 and dividing it by 0.8, because you divide both sides of this equation by 0.8. So therefore x will equal this, which, as Karina and 1 Million Sloth said, is 3.125. So if you were putting it in money, instead of 3.125, you might write £3.13, because you can't have half a penny in the UK system anymore. Cool. Okay, great. Right. Let's see now how many people followed that by going up here. So let's say that Charles Darwin is looking for insects. Charles Darwin was so obsessed with collecting insects that when he went on field trips and he ran out of pockets to put the insects in, he would literally store them in his mouth. Like, there was so many times that he would come back to the boat and his mouth would have loads of like insects inside that he was just wanted to bring back so that he could study them. So I'll draw little insects going to his mouth. Darwin was pretty cool and pretty extreme and pretty weird, and it would have been really interesting to talk to him as a human being. Anyway, so right, let's say Darwin has discovered let's say he's discovered like 207 insect species, and this is 30% higher than the number of species he had a year ago. So a year ago he'd discovered an unknown number of species, which I want you guys to work out. And a year passes and he discovers 30% more species, and now he's discovered 207 species. So my question to you guys is, how many species did he know about the year before? What do you think? First, I would want you to like maybe draw out a little diagram to help you visualize it. So fill in all the information we know. So we know that after the change, he knows 207 species. We know that this is with an increase of 30%. So if you're increasing by 30%, and you start with 100%, increase by 30%, so that's going to be 130% of the original. So it's times by 130%. And that is starting with our unknown number of insects, which is x. So our unknown number of insects increased by 30%. So times 1.30 or 1.3 gives us 207, which means that the number of insects before must have been 159. Yes, that is great. Right, let's do one more of these changes. So let's now look at Darwin's head cover. Let's say his head is got like 45 centimeters squared covering. So he's got 45 centimeters squared covering because he's going bald. So this is actually down from last month. So a month ago, yeah. So he had his head was covered in more hair before, and it's actually he's had a reduction in hair cover of let's say 42%. So his hair cover has dropped by 42%, and now he's only got 45 centimeters squared covering of his hair. So what hair covering did he have before? If he's got 45 centimeters squared covering now, and that's because of a decrease of 42%, then what does that mean he had before? So again, I'll help to draw you a little map so that we can do this reverse percentage. So here's Darwin's hair covering. And if you label how much hair he had before, then we don't know how much he had before, so let's just call that X. And after, he's got 45 centimeters squared. And that is after a reduction of 42%, minus 42%. So if he's losing 42% of his hair, then that is the equivalent of him having 58% of the hair he had before. So he's now got 58% of the original. So minus 42% is the same as 58%, because if you start with 100%, you take away 42%, that gives you 58%. So we start with the original amount of hair, and if you reduce it by 48% by timesing by 0.58, then that should give you the new amount of hair, which is 45, which means that the old amount of hair would be 45 divided by 0.58, which is going to be 77.6 centimeters squared. Perfect, great. So yeah, Darwin used to have a lot more hair. Only a month ago he had 77.6 centimeters squared, and now he's down to 45 centimeters squared because there's 42% reduction. Cool, okay, right. We spent most of the time on percentages. I'm now going to switch over to fractions. Let's go over here to this big old seal. Okay, so fractions. This is another thing that I found was not explained to me very well in school, and maybe you've had a similar experience. I think that fractions are quite a lot simpler than it's often made out, and they're kind of taught in this way in isolation of being like, oh, that's a fraction, that's like this weird thing that behaves weirdly and you have to learn these rules. But actually fractions are quite simple when you understand why they're written in the way that they're written, which took me ages to figure out. So first of all, have you ever noticed that the division sign is the same as a fraction, where the dot on top is the first number and the dot on the bottom is the second number. So 3 divided by 4 is exactly the same as 3 over 4. It's the same thing. 3/4 is 3 divided by 4. And this is true of any division. So there will actually be lots of times that you might be finding a division quite difficult, or you might be thinking, oh, this is going to take loads of effort and energy to work this out. For example, if you're asked to do 450 divided by 5, then it's often a lot easier to just start by writing it as a fraction, because it's the same as 450 divided by 5. And then you can often start cancelling it down in ways that might seem simpler. So that's the first thing to note, is that a fraction is the same as a division. And a lot of you may have already known that, but that's just the first point that needs clearing up. Point number 2 is that in a fraction, the top is all the stuff you times by. So I kind of think of it as the timesy stuff. The timesy stuff goes on the top, and the dividey stuff goes on the bottom. Oh, that's the dividing stuff on the bottom. So, for example, if you are told to do 3/4 of 16, then what that means is that for 16, you're going to times by 3 and divide by 4. And you can do that in either order. 16 divided by 4 times 3 will give you this answer. So that's going to be 12. This means that you should now be able to work this out quite easily. So if I say times this by 3, what do you get? So that's question number 1. And if I would say divide this by 5, then what would you get? And that's question number 2. Okay, so Karina's saying 9 over 4 and 3 over 20, which is brilliant, nice. Okay, so for those who didn't follow that so easily, all the stuff you times by on a fraction goes on the top. So if you're timesing by a number, it goes on the top. So some people make the mistake of thinking 3 over 4 is the same as 9 over 12 because you've times the top by 3 and you've times the bottom by 3. But actually, this doesn't make any sense because you can simplify 9 over 12 by saying, well, 3 goes into this and 3 goes into this, so therefore it must be 3/4 by dividing the top by 3 and dividing the bottom by 3. But how come you've taken 3/4, made it 3 times bigger, and then ended up with the same number? Doesn't make any sense. So the key thing to remember is that when you're multiplying a fraction by a number, you only multiply that number onto the top. So 3/4 times 3 becomes 9/4. Similarly, when you divide by a number, you just times it onto the bottom. You will notice as you get older and you kind of progress through doing maths that the divide sign actually kind of disappears because instead of using divide signs, we just times the number onto the bottom of the fraction. So 3 over 4 becomes 3 over 20. It becomes 3 over 20 because you times the 5 onto the bottom. So 3 over 4 divided by 5 becomes 3 over 20. Cool. And those are two of the kind of key points that I wanted to make sure you guys learn about fractions. And so I guess actually this is probably a good place to end. So I'll just end by telling you one quick story about this seal. The story that I wanted to tell you guys is yawning. If you see someone else yawn and you yawn as well, then that means that you're like empathetically connected to that person, so you understand them. Well, I'm wondering if anyone here feels like they don't yawn so much when they see other people yawning. That was a fake yawn, but maybe it would make you guys want to yawn, which would be interesting. But I once saw, when I was on like a little boat trip, I once saw a seal yawning, and it really affected me. Like, I had one of the biggest yawns of my life watching the seal yawn, and I wonder if that's because I'm empathetically connected to the seal. Anyway, please do follow our socials, which you can find there if you haven't already, and sign up for the schedule up here if you haven't already, and also do please tell friends and family and everyone else that you can think of that we're running the big catch-up for one more week. And if people want high quality live interactive lessons that they can ask questions at any time, then tell people to come find us at AimHi. Thanks so much for watching, everyone, and do, as I said, throw your feedback into the chat because I would love to see that, and I will see it for the next like minute or so after I've finished the lesson. So yeah, that'll be great. I shall see you all soon. Farewell, bye.